Hi, my name is Maisarah Binti Faisal. My ID is CA20155. For this video, I'm going to present about API for Network Automation. API stands for Application Programming Interface, specifies how software components should interact and allows different systems to exchange data and functionality. For example, the travel service website interacts with the various airline databases using APIs provided by each airline. When user enters the information to make a reservation request, the website interacts directly with the airline's own database and provides the user with information matching the user's request. APIs can also enable different software systems to communicate with hardware devices, such as sensors or printers. In the context of network automation, an API allows you to interact with a network device or network management platform to perform tasks such as configuration, monitoring, and provisioning. There are three types of API. Firstly, the internal APIs or private API. These APIs are used exclusively within an organization. They are restricted to specific members. Financial apps is one of private API where it manages all aspects of finances, from checking and savings account to credit cards. Secondly, public APIs or open APIs. They are designed for external consumers and can be used with no restrictions. Public APIs example is PayPal. It instead sends the purchase order to the PayPal API and PayPal handles the rest of the transaction. Finally, the partner APIs. These APIs allow business partners to access functions such as online catalog, ordering, reconciliation. The business partner must have license or some kind of permission to use the API. A travel service using an airline's API is an example of partner API. There are many different types of web service APIs available for network automation, each with its own set of capabilities and features. Some common APIs used in network automation include SOAP, Simple Object Access Protocol. It's a protocol for exchanging structured information in the implementation of web services in computer networks. It uses XML as its message format and relies on other application-level protocols such as HTTP for message negotiation and transmission. Next is REST, Representational State Transfer, are built using the HTTP protocol, which is the standard protocol for communication over the internet. A REST API for network automation allows to manage and automate tasks on a network using a RESTful interface. It applies URI, which is Uniform Resource Identifier, and HTTP methods such as GET, POST, PUT, or DELETE. The API endpoint will then process the request and return a response in the form of an HTTP status code and a payload, which can be in a variety of formats such as JSON or XML. XML RPC and JSON RPC are both have the same tasks such as configuration, monitoring, and provisioning. However, the thing that differentiates them is XML RPC protocol uses XML, while JSON RPC uses JSON protocol to encode its calls and HTTP as a transport mechanism. They allow a client to remotely call procedures on a server and is often used in network automation to perform tasks. The server will then execute the specified procedure and return the result in the form of a JSON and XML response. The advantage of JSON RPC and XML RPC is that it is simple and easy to use, as it only requires basic HTTP knowledge and does not have a complex data model like some other APIs. However, it can be less efficient and less flexible than some other APIs as it does not support features such as streaming or multiplexing. Now, let's move on to a RESTful API. RESTful API is an API that follows the REST architectural style and constraints. Here are some key points to consider when designing a RESTful API. Firstly, it should use a URI to uniquely identify each resource. Next, it should use a consistent formatting for the data sent and received, such as JSON or XML, to ensure that the API is easy to use and understandable. Some of the key features of RESTful web services are the client-server architecture, where the client, such as a web browser, handles the front end and the server handles the back end. Besides, RESTful web services are stateless, meaning that the server does not store any information about the client between requests. This allows for scalability and makes it easier to maintain the system. Next, RESTful web services can be designed to be cacheable, which means that the server can specify whether a response can be stored by the client, such as a web browser, and used in the future without needing to send a new request to the server. Move on to the next topic, which is the differences between URI, URL, and URN. A URI, Uniform Resource Identifier, is a string of characters that identifies a name or a resource on the internet. It can be broken down into two types: URLs, Uniform Resource Locators, and URNs, Uniform Resource Names. In summary, a URI is a general term that refers to any string that identifies a name or a resource. A URL is a type of URI that specifies the location of a resource, while a URN is a type of URI that identifies a resource by name. In the example provided, the URI for the MapQuest Directions API is used to request directions from San Jose, California to Monterey, California. The request is made using the HTTP GET verb, which specifies that the client is requesting data from the server. The server then responds with a payload containing the requested directions, which could be formatted in JSON or some other format. It is worth noting that RESTful web services are designed to be stateless, meaning that each request is independent of any previous request. This allows the client and server to communicate without having to maintain a persistent connection, which makes the service more scalable and easier to implement. It is common for RESTful APIs, including public APIs, to require a key for identification and authentication purposes. Here are some reasons why an API provider might require a key. Firstly, API keys can be used to limit access to the API to only authorized users or systems. This can help the API provider control the number of requests made to the API and ensure that the service is not being overloaded. Secondly, API keys can be used to track usage of the API by different users or systems. This can help the API provider understand how the API is being used and identify any potential issues or trends. Lastly, some APIs may use keys to track usage and charge users for their usage of the API. This can help the API provider generate revenue and sustain the service. There are many ways to make RESTful API requests, and the method you choose will depend on your specific needs and goals. Using a web browser to make API requests can be a quick and easy way to test and debug an API. As well as to get a feel for how it works, this can be especially useful if the API developer has provided documentation and examples on their website, as you can simply follow along and try out different API endpoints and parameters. Postman is a popular tool for testing and using REST APIs. It provides a user-friendly interface for constructing and sending API requests, as well as for viewing the responses. It can be especially useful for testing APIs with a variety of different endpoints and parameters, and for saving and organizing API requests for later use. Python is a powerful programming language that can be used to make API requests and process the responses. This can be useful for automating API requests, integrating APIs into applications, and customizing API requests for specific needs. Finally, network operating systems such as netconf and restconf provide a way to configure, monitor, and manage network devices using REST APIs. This can be especially useful for managing large networks, as it allows for programmatic control of network device and the ability to automate tasks such as configuration and monitoring.